So hi guys, good afternoon. So I want to believe you've seen the video I sent yesterday, where we were able to discuss some of the um, other data types. We discussed the list. We also discuss tuples. We discussed sets. We discussed dictionary, right? And we told us that sets are immutable, strings are also immutable, and tuples are also immutable, but a list is mutable, meaning it can be changed. We talked about what we can do with lists. We talked about how that we can append to a list, we can extend a list, we can pop a list, we can remove from a list, we can add two lists together. We can also index a list, all right? Index a list by taking a position, all right? We can index a sublist. We can also use the index function to get the index of a particular part of a list, all right? And then we talk about sets, how that we can do intersection, we can do merge, we can do union and all that. So today we're going to look at loops and functions. So we are starting with loops, right? In Python, we have three different types. We have the, but before the loops, let's talk about the if statement, all right, which I've discussed before now, if statement, right? The if statement is in this form: if the condition. So let me just put here that the syntax goes like if, then the condition, then there is always an ident, meaning a space, and then you can now put your statement, right? Of course, we can have if s. For if x, that will be if s. In that case, you have if the condition, if the condition, then your statement. So we can also now have else if. I think we did a bit of that. Else if the condition, after the condition you put a semicolon, semicolon, then the statement as well. But before the and after that, sorry, we can now have the else, right? This is the last part. And then the statements. So this is the flow for an if condition, all right? So I can say, let's say A is a list, all right? Let's say the list consists of these numbers, and then I can say if A, if 3 in A, remember our in operation yesterday and not in. If 3 in A, then we can see this is the ident because there is now a space. It's not starting from if, it's having a space. So by default, it does that. If 3 in A, then print, I can put a statement here, print the answer is wrong, right? So I can put again, I'll come back, I'll jump out of that loop, that's why we call it. Then I'll come back to this position. Else if L if it's, let's say, in F if, let's do len, L if len of A L if len of A, we are doing to double equal to, because we want to say is it the same, is 5. Then print, can say too long. All right. So for this part class S, we can decide not to put any condition. We can decide to see put a condition else. So most times you don't need to put condition else, because that's the last statement. S print. Now there is a data type called none, right? So when I say S none, what I'm saying is that don't return anything. So if I run this now, you can see it's saying if 3 in A, it's saying the answer is wrong, right? You see? So, but let's say we will change this to 4 now, because len of our list is 4. Let's see what we have if we run this. If len of A is 4, you should print too long. Let me see. So yes, double. The len is 4. You should. Okay. Is giving us the first statement, because the first statement is false, right? We can't have all the statements together, right? So what I can do is, for example, I can run this together and bring this here and bring A together with this. Boom. Control V. All right. Then I can change this to. So if you run this now, you can see it's saying too long. If len of A is 4, print too long, and the length of A is 4, so it has to print too long, right? So this is if statement. You can also do nested if. So let's say, for example, A is okay. Let's say B now. We have A already. B is 3 and 4. All right. I can do conversion. Conv. I want to convert both A and B. So let me do conv A. Remember, we can divide two variables together, conv B. So in that case, I will now say for conv A, I want to say convert A to set. And then B also to set, right? I can run this, right? I can now, because A and B, if I print A now and I print B, if I print A, you see now that is now, it should be a set now. What's happening? Let me try B. Okay. Oh, sorry. I was supposed to print conv A. So conv A is what has changed. You can see. And I say, if I say conv B as well, because conv B has the name as set. So I can do an if statement now. All right. And I'll say if A or let me just say, if 3 in A, right? And if this is nested if now because it contains another if. That's why I call it nested if. If I want to say if 3 is in A and len of A, and so I'm not doing and here. So I'm saying if 3 in A, and again, if len of A is 4, you can see this is nested with there. You now print yes. So if I run this now, you can say it's printing what? Yes, because it's doing a nested if. First, how nested if work is, it checks the first condition, is it true? Then if it is true, it checks the second, is it true? Then because before it now execute this last one. Now, for example, if the first one was true and the second one was not true, then it will not return what we ask is for. Let's say we said if 3 is in A, to check, okay, 3 is in A, correct. If len A is 5, okay, len A is not 5. Print yes, it won't print yes now because you can see now it won't print yes, except we now do an else and say print no. Now if you run this now, you can see it's printing no, because based on the nested if, right, it is not supposed to be a yes but a no. So this is how you run a nested if in Python. And remember, we've converted our A and B to what? To set. So I can say, I can do another if statement. If A dot intersection, remember, or what do? I can use pipe, right? A intersection B, but we are not using A intersection B because we converted A and B to what? To set. So, and the name we gave it using this definition of variable here, conv A, conv B. Remember, we can divide two things together, and conv B. If the intersection is, you know, the intersection is 3, Abi. What is the intersection between this? If it is 3, then print cool. For example, if I run this now, we should be having cool. If conv A intersection conv B is 3, so because the intersection of truth is 3. Okay, let's see. Okay, let's put an S rather. S print bad. Let's see. It's same bad, but the intention is 3. Let's check again. Conv B, this is 3, 4. Yes, intention is 3. Okay, so we can try this singly first. So let's do Control V. Oh, sorry. Pipeline is doing sorry. Pipeline is for union, Y and is for intersection. Sorry. So let's run this now. Let's run this. Okay, let's change it here. Let's see. Okay, 3, which is correct, right? Okay, let's do it this way. Let's see. Okay, so we're supposed to put it in a set, right? So if convey intersection conv B is 3, then print cool. You can see that we have cool printed. But if it were to be pipeline, we are talking about union, right? So, and then difference and all that. So this is how you execute if statement. So let's talk about the loops that we have. So the loops we have the for loop, we have the while loop, and we have the for while loop. All right, in this video, we'll talk about the for loop first. Now, it's very simple. The syntax is for value in items, then you put your, so you can now put your, or let me just say for condition, or let me put it that way, or you can just say, instead of using that, say condition, then print remember your print must be in small letter, right? Print, or let me just say statements. So these are for loop works. The same thing, you can have a nested for loop, nested if loop. You can have a nested for loop. All right, we'll try that now out. All right, so let's take an example. I can say for I in, I can put a list. Let me do my list of A. Remember our A. For values in A, print high. So what does this mean? This means I'm checking my list A, and I'm saying for every value in A, print them out. I is each value. For each value in item A, which is 3, 5, 6, which is a list, print all of them. So it will now list them out as in each row. You can see 3, 5, 6, 8. You can see 3, 5, 6, 8, right? So I can also say, okay, print I times 3, meaning I'm saying each value of I, multiply it by 3. That's what this does now. You can see it has multiplied each values of I, multiply it by what? Pi by 3. So this is how you carry out a for loop, right? Now, I can do a lot of things with this. I can initialize as well. Let's say I want to add every value in this list. 3 plus 5 is 8 plus 6, 14, 14 plus 8, 22. I can do that. How do I do that? How do I do that? I can do a for loop. But before I use a for loop, I must initialize a value that will not add to my list. Now, what value can I add to these values that will not add to my list? It is only 0. If I'm adding 0 to any number, it's still that number. So I can initialize a 0. Let's say 0. Sum is equal to 0. I now do my for loop for I in A. Right? I can now say sum equals to, that is the summation of every of my list, is equal to sum, which is 0, plus each value of A, right? So sum plus high, because high is the value of each. Yeah, so high is 3, I is 5, I is 6, I is 8. So I'm saying for each of these value, add 0. Add 0. So now it's just like, for example, let me give you an example now. So if the first one is sum equals to, the first one is 0 plus what? 3. Now what is my sum now? My sum in this case now has become what? 3, right? So the way for loop work is not until it reaches the end of that loop, it won't stop, right? Because this sum, this statement is under sum, so it's still going to continue on that loop, right? Until the statement is no longer true. Now, until it exhausts every value in this A value, which is till 8, right? Now, this is what the first value will give you. Now, what are sum turned to? Remember, sum is sum plus I. So sum is still sum. So in the next one now, sum will now be what? sum plus I, remember, is sum plus I. The first value was 0. Now it has increased to 3. So sum will now be 3 plus what again? I. What is the next value of I? I'm just using this to explain. 3 plus what? 5. All right, which is 8. Now, sum again. That's how this will continue to execute. Sum again has increased its value. Remember, this is the function we are using. Sum equals to sum plus I. So sum has increased to 8 again. It will now become 8 plus, look at the next value. Okay, sorry, it should even be 6 already. So let's just change. Okay, 5. Oh, sorry, it's correct. 8 plus the next value, which is what? 6. 6. Sum is now 14. If you look at again, sum again, looking at this first statement, because this is our formula itself, sum is now what? 14 plus the final value in I. You know, I is about 8. So it's plus 8, which is now what? 22. So if I now say print sum now, so I have to go back to the end of the loop. Oh, sorry, I still need to remain in a loop. Print sum. All right, so immediately I say print sum now, the answer I will get is what? 22, which is the final answer, because it has exhausted everything in the list A. So this is how this works, right? Let's try this out. Let's remove all this, and then now if I say print sum now, if I execute this now, you see that it's adding it up 3, 8, 14, and then 22. But if I don't want everything, because it's in the for loop, so it's executing it one by one. 3, 8, 14. But if I don't want this sum, right, to show these initial values, but to show the final answer, I will just remove myself from that loop. That's why it's called a for loop. I will remove myself from that for loop. Immediately I press back arrow, and the print is starting from where 4 started. I've moved away from that loop, meaning I've removed myself from the loop. When I print it now, when I run this code now, it will print the last value. You can see it's printing the last value. So this is how you do for loop, right? Now I can decide, instead of writing it directly this way, I can decide to, instead of this same code, there is another way I can write that. I can write it as instead of writing sum is equal to sum plus I, there is a shortcut to this. I can say plus is equal to I. What does this mean? This is shortening, this is saving me of writing sum twice. So instead of saying sum is equal to sum plus I can say sum plus is equal to I. So it's the same thing as saying sum is equal to sum plus I. This will also give me the same answer. So if I run this, you can see I'm also getting 22. All right, this is how you run your for loop. All right, now you can use your for loop with range. So range is a function. All right, range is a function which has the following argument: the start, the end, and the steps. What do I mean by this? So I'm saying the start is where you are starting from. Maybe I want to call in 20 numbers, for example. So 20 number, the start is what? Let's say I'm starting from 1, right? The end is what? 20, Abby. So 20. The step is what I'm omitting. So if I'm doing 1 to 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, like that, 1 to 20. Then that one is I won't my step, I don't need to put step, or I can put step to the 0. Or I can say step is 1. Sorry, step is 1. But if if there is a need for me to steps maybe by 2, I can say okay 2. So meaning I want to return in 1, 3, 5, 7, 9, 11. So that's the meaning of that step. If I put 3 here, meaning I'm omitting 2 numbers. So 1, 4, right? I can decide to start from 2. 2, 4. You can, that's if the step is 2. 2, 4, 6, 8, like that. So those are that's what the range function takes, right? So range is of this syntax. This is syntax. So I can use the start the step. So right, and now the only thing is if I do 2 to 20, it will not count. It will always exclude the last number. So if I want to add the last number, which is 20, I have to do +1 so that it will do to the last 20. So what that means is if I need 1 to 20, I need to say start from 2 or 1, right? And then end at 21. So that 21 will just count till 20. It won't add 21. So that's how it works. All right. So let's do an example with that using for loop. So I can say instead of saying for I in A, so I can say for I in range. So I cannot specify. So the values I want it. Okay, let me just do an example first before you see. So let me print range. So I can add one argument as well. So if I say print range 20, for example, so you say the first 20 numbers, that is to 90. You can see range 0 to 20. 1. Okay, yeah, not okay. Wait, let me see. So it's only when you use it in an argument of 4. Yes, I remember. So don't know when you use it in an argument of 4. Okay. Okay. So let's put it in our for loop now. For I in range, yes. So I in range 1 to 20, but we need 1 to 20. So for us to get 1 to 20, we have to put 21. Right? Then print I. Print I. So if you print I now, you see that it's printing what? The first 20 number. Remember, if I want to remove myself from that loop, it will not work, right? So print I. You can see that I have 1 to 20 printed. If I want 2 to 20 and I want steps, you can add steps. And that you can see 2, 4, 6, 8, 12, like that. So now let's now use it to write a query of this sort. For I in range I in range 2 to, or let me just say, yes, 1 to 11. So that's to say 1 to 10, right? I can say print. So I want to say print I times 5. So meaning it will multiply all the values of I by what? By 5. You can see that. I can also specify. I can also specify. Let's say I want this value in a list, right? I can say list. List is like this, right? I can say append this I to a list. So I don't want the value like this. I can say list dot append. Remember when we're talking about append, list dot append I. Then I can now say, so I can give this one a name, my list, for example, equals to list dot append I. Then I can now say print what? Print my list. What I'm saying is that my list does append I, meaning to this empty list, keep appending the values of I that we know. So to append 1, 2, 1, 2, 3, 4, like that to 10, right? So into that list, so that I don't have it single value like this. So if I do this now and I say execute, okay, sorry, I'm out of that loop. So if I say execute now, okay, list does append. Okay, let's say print list. Let's see. Okay, so great. So you can see now that but we don't want, let's remove this. Okay, so you can see now, but we don't want, so list does append I, then we just print that list. So, and then you have it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see now that we have our values in a list, all right? So this is how for loop works, right? Then the last thing I want to do here is, let's say to this list now, I'm appending I, right? And to this list again, I want to multiply by 2, for example. So I can say list. So I can now name this one, let's say list equals to list times 2. So let's run this. You can, oh god, sorry. So it's going to duplicate that. Okay, wait, let me. Yes, so list times 2. Remember what list times 2 does? It will make double of that list, 1 to 10, right? And then 1 to 10. Now that's how this works. Now, but in case okay, so in case you want to multiply each value of that list, we can still do something. Let's also print this. We can do something like, okay, for I in list, right, in that range, I equals to I times 2, all right? Then we are now appending that I, and then we print that list. So this one now, this code now will now multiply this I, sorry, this is I times 2, which makes it what? 2, 4, 6, like that. You can see now that multiplied it by 2. Then after that, we now appended. So this is what we call data structure. You have to know how the structure is, and then so this is about for loop. The last thing I'll be talking about here is we can also achieve nested loop, right? So I can have 2 for loops together, right? I can say for I in range, let's say 1 to 10 or 11 now. So now remember this one we're doing where we multiplied. Where is the place? Okay, I will show something. So now again, I can do a for loop to now do another one. Say for I in range 1 to 11 again. So for not instead of 1 to 11, I will now do high to 11, right? Sorry, let me change this one now to J. For J in range, sorry, 1 to high. 1 to I. Yes. For J in range 1 to I can say print I times J. Now, you can see this. 2, 3, 4, 2, 3, 6, 4, 8, 12, 5, 10, 15, 20, 6, 12, 18, 24, 37. Okay, wait. That should be I to 11. Let's see. Let's run this. Yes, yes, this is it. Yes, this is it. 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 Okay, let me check that. Is it complete? So 1 times 1 times 2 to 10, 2 times 1. Okay, times 2 to 10. 3 times 3. Okay, okay, okay. Okay, so what this is doing now is it's reducing it, so we don't want it to reduce it. I minus 1. Let's see this. So 2, 3 times 1. So 0. So let me put a space. Print next line. Next line. Okay, so that there can be space. All right. After each loop. Now, what this is doing is you can see now that for I in range 1 to 11, what should that bring to you? 1 to what? 10. We now do a nested loop that if this first one is true, then for J in range I minus 1, let's do I first. I to 11. So meaning we are looking at I again, the values in I, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looking at those values, let's run it again now. Yes. So you can see that we are now looking at then to range 11 again, starting from I to 11. So this one runs first. So if I here is 2, then J will start from what? 2. Because that's where I is. J will start from 2. Right? If I is 3, J picks 3. If I is 4, J picks 4. So we now multiply what the value of I at that level is. So 1 times 1, you have this. 1. So when I moves to 2, it becomes 2 times 1. So I, sorry. So I execute first. So I 1, 2, 3, 4, 5, 6, 7, 8, 10. So then J in range I. So for every time the I is increasing, Abi. So we take J, which is starting from first of I. So I times 1, I times 2, I times 3, I times 4, I times 5, and then that's why you have this to 10. Then it moves again. The next value of I is 2. 2 again. 2 times 1, 2 times 2, you can see, because J is also increasing, times 3 times 4, you can see, times 5 times 6 times 7, like that. Then again 3, but now it's reducing, right? It's reducing, which should be complete for all, which is where we will adjust, right? All right, so okay, let's change this. Sorry, this should be 1. This should be 1. So for I in range 1 to 11, because it's multiplication table 1 to 10. 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5 times 6 to 10. 2 times 1, 2 times 2 to 10. 3 times 1, 3 times 2 to 10, like that, and then to 10 times 1. So we just say for I in range 1 to 11, for j in range 1 to 11, print I times j, and then you can print this. Let's see. You can see 1 to 10, 2 again, 2 times 1 times 2 times 3 to 10. 3 times 1, you see, this is a multiplication table, and then it does that to 10 as well. So this is how you can print this. So let's just format it. Instead of just saying I times j, we can say I. So we can do I print I. So we can put that in. So I, then you can put in quotes times. So do I, comma, times. So let's put a space here, times, comma, times, comma, j, equals to. So because we want equals to there, so you can say print equals to inside double quotes equals to, comma again, then I times j. So this now we say I times j, so then equals to, let's run this. So you can see now the space is much. You can reduce it. Let me need more space. So you can see now 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5, like that. I hope you get this. So, and it does that till you have this. So this is how we can do nestless loop. In our next class, we'll talk about while loop and some other nice examples. I hope you got this. Thank you. Bye.